Welcome back, guys. In this video, we will start combining our knowledge on matrices that we learned in the previous videos, and especially for what concerns the inverse and the system of equations, and some static knowledge, basic static knowledge, with our knowledge on the script and how to use MATLAB in order to solve any engineering problem. So a good example is this one. We have here a truss and we have an external force here that is equal to 1000 Newton. We have some reactions to be found. So basically, guys, if I need to find the unknowns that are here, H2, V2, V3, I should also find the internal forces. The internal forces inside the truss. Here, one internal force. Basically, here I have one internal force, and here I have one internal force. And I know that in each member, this internal force will be opposite to another internal force that is also equal. So basically, guys, what I'm gonna do, I'm gonna put the equations governing this truss and make the projections on X and Y using the joint method. And then, guys, I'm gonna solve this problem using MATLAB. Okay, so guys, this is a schematic of the truss. I'm gonna call this internal force F1, this internal force F3, and this internal force F2. So let's start, for example, by joint 1 in X. If I'm gonna take this joint 1 and do the projection on X, what I should have is minus F1, which is this one, minus F1 cosine 30, plus F3 cosine 60 is equal to 0, because in fact this is vertical. This angle here is 30, this angle here is 60, right? Now, in Y, I should have minus F1 sine 30 minus F3 sine 60 minus 1000 is equal to 0. So this is joint 1. Now for joint 2, this is joint 2 here. I have F1 and F3, and I have these two reactions. So in X, of course, I'm going to have H2 plus F1 cosine 30 plus F2 is equal to 0. And in Y, I should have F1 sine 30 only. I don't have any other forces. I have V2 plus V2 is equal to 0. And then joint 3. So what do I have in joint 3? I have in X minus F3 cosine 60 minus F2 is equal to 0. And then that F3 sine 60 plus V3 is equal to 0. Okay, so let's take a look to make sure that I don't have any error. So this is minus F1 cosine 30 plus F3 cosine 60 plus 0 is equal to 0, minus F1 sine cosine 30 sine 30 minus F3 minus 1000 is equal to 0. They are all downward. And here I have H2 plus F1 cosine 30 is equal plus F2 is equal to 0. And then what do I have here? F1 sine 30 plus V2 is equal to 0. And then for joint 3, I have minus F3 cosine 60, yes, minus F2 is equal to 0. And then F3 sine 60 plus V3 is equal to 0. Yes, that's it. So here, guys, as you can see, how many equations do I have? I have 6 equations with 6 unknowns. What are these unknowns? They are the reactions and the supports H2, V2, V3, as well as the internal forces. So I need to solve this system of equations. 6 equations, 6 unknowns. Remember, we said that in matrix, I can define A, where A is the matrix coefficient, times X, which is the unknown, is equal to a constant B, and then I can find X as what? As inverse of A times B. So this is what I'm gonna apply here. So what my purpose is to find A, which is the matrix of coefficients, as well as B, which is the constant matrix. And then, guys, I'm going to find X as the column vector, including all the unknowns that are here, H2, V2, V3, F1, F2, and F3. So basically, guys, try to conserve your order. So first of all, define this X. So in this order, let's say you're gonna start with F1, F2, F3, and then H2, V2, V3, so that you can find the coefficients of these unknowns in A, and then B will be the constant. So this is what I'm gonna do here. So basically, guys, I will define X starting by F1, F2, F3, H2, V2, and V3. So this will be the order of X. Now you're going to see why is this order important. And then A will be what? A will be basically the coefficients of these unknowns, and B will be the constant. So let's start doing this using MATLAB in the next video.